Hi everyone, I'm PawseyInternPDave, and my project this summer was titled Scaling the SKA Science Data Processor Imaging Software in Setonix, and it was based with the SKA Observatory. So this year, I'll be entering my third year of study in a Bachelor of Mechatronics Engineering at Curtin University. As a huge space and science nerd, I was ecstatic when I heard that I was successful in acquiring my Pawsey internship this summer, and more specifically with the SKA Observatory, where I would get to work on the radio telescope being built in the northern parts of Western Australia. So the SKA project is made up of three parts: the SKA headquarters, which are situated in the UK, then the SKA Mid Telescope in South Africa, which will observe the high frequencies of radio waves, and finally SKA Low here in WA, exploring the lower frequencies. So once the telescope is built, it will be able to look back in time to the beginning of the formation of our universe and finally answer our burning questions, such as, did the Big Bang really happen? However, it will also produce terabytes of data per day that will need to be received and processed in real time and converted from radio data, also known as visibilities, to an image that is visible to the naked eye. My project this summer was to first learn interferometry. This is the method used to convert visibilities into an image. It is an iterative cycle where we switch from gridding and degridding the visibilities on a UV plane to a matrix and vice versa to remove the errors captured on the UV plane. This is known as the major cycle. Then by doing normal and inverse fast Fourier transforms and by using a deconvolution algorithm such as clean, the image is literally cleaned. The first image ever produced is known as a dirty image, and it is repeatedly cleaned to produce the final model image. This is known as the minor cycle. After learning the basics of interferometry, I moved on to running an input-output test on Pawsey's supercomputer, Setonix, to test the degrid speed. We ran a dry and non-dry test where visibility data results were not written with the dry test. As you can see in both the datasets, which is SKA low and datasets for the very large array, the dry run was much quicker in both, as usually writing out the visibilities is always a bottleneck for any task. Both of these were tested with a different number of nodes and processes, and also as seen and expected, the fastest speeds were recorded when the most amounts of nodes and processes were being used. Then the final step of my project was to run a deconvolution algorithm, WSClean, to create an image. WSClean was written by a PhD student and is currently being used for the Murchison Wildfield Array, another radio telescope in the northern parts of WA. Although not 100% compatible with the SKA, it was the closest we had available during my internship. The first time I ran WSClean, it was merely to check if it had been successfully installed on Setonix, so it was done on a very small and random dataset, as seen on the left. After this, I found a bigger dataset on the Confluence page recorded by SKA Mid. This is the image shown on the right, and it is a much better image than what was produced on the left. This also took 2 hours to process, only on one node, and another hour just to transfer data in and out of Setonix and my local computer. This is my poster that I used for the Pawsey showcase. And so the plan for the future is to develop our own deconvolution algorithm that is specifically written for the SKA. WSClean could be optimized or adapted for this, or it may have to be written from scratch. We can also use both IO test and WSClean results to better inform the future procurement for the supercomputer for SKA Low. Overall, this internship has taught me a lot: how to use a supercomputer, parallel programming, how to write SLAM scripts, and of course the physics side of things such as interferometry. As well as all of this knowledge, I've had so many opportunities to network with not just other industry representatives, but other like-minded interns and my amazing SKA colleagues. A huge thank you to my supervisor as well. Despite being in Rome, he made sure to catch up with me every single day. And of course, thank you to Pawsey for giving me this amazing opportunity.